Welcome dear students. In this video lecture we are going to learn how to draw the front and top views of a solid when its axis is parallel to VP and inclined to HP. This is the very similar problem which we solved in the last class, and in the last class we solved for a prism, and today we are going to solve the same for a pyramid. And this is the problem in the second half of our problem set. If possible, you please write the problem in the paper. And this is what the problem: a square pyramid of base side 40 mm and axis 65 mm is resting on HP on one base side. The axis is parallel to VP and 30 degree to HP. Draw the projections. So yes, the object given in this problem is a square pyramid, and its base dimensions are given. The base side as 40 mm, axis height as 65 mm. It's going to rest on HP on one base side, not with a base corner or with a side edge or with any other thing. It's going to rest on HP by one of its base side. The axis is parallel to VP and 30 degree to HP. So this problem is under the category axis parallel to one plane and inclined to another plane, and you have to draw the projections. So in that case, first you have to start with the XY line. Let me to draw the XY line here. Yes. And this, as usual, we have to start the answer by asking two questions with the problem: where should be the base and how should be the base. And as per this problem statement, the square pyramid is rest on HP and the axis inclined to HP and parallel to VP. So in basic, the axis will be like that when the solid is resting on HP when you view it from the front. So its axis is inclined to HP. So as usual, what you need to do is you have to make the axis perpendicular to HP in order to view the base of the solid from the top view. Okay, so it is easier to make the axis perpendicular to HP instead of making the axis perpendicular to VP, because in this 3D environment the solid is standing like that. So the axis is only inclined to HP and parallel to VP. So we need to make this solid straight. So when you make it straight, automatically the axis will become perpendicular to HP. The solid will made in this way. In this way, so the axis will become perpendicular to HP and parallel to VP. In that condition, you can see the base of the solid whether in front view or in top view. In the top view only we can see the square base of the solid. So in this problem you have to start the top view. Okay, in the top view only you can start with the base. So in always in a projections of solids problem, you have to start the answer by the base view. First you have to find out where the base view will obtained based on the current situation. In this problem, when you tilt the axis perpendicular to HP, the base view will obtained in the top view. So you need to top the answer from the top view. And the second question is how should be the base. In this problem, the solid is going to rest on HP by one of its base side. Okay, one of its base side. So you need to advance a base which should be perpendicular to VP. Then only at the time of drawing the tilted view, the solid will rest on HP by one of its base edge. So this arrangement will reflect in the third step. So this is your first step, second step and third step. When you make one base edge perpendicular to VP in this first step, then automatically that base edge will come and rest on HP when you tilt the solid lateral view in the third step. So in this problem also we need to draw the square base of the solid perpendicular to one base side perpendicular to VP. So let me just draw the base view of the solid. The solid dimensions are given. The solid base side is 40 mm, and since it is a pyramid, it's going to have the apex. So we need to join the diagonals in order to mention the slant edges, and the apex point can be named with the alphabet O, and rest of the base corners may be named with the alphabets. And you have to draw the projectors to facilitate the drawing of a front view. I need to project the apex point also in order to locate the axis as well as the apex point in the front view. Here, for your understanding purpose, I am making dots in order to mention the base corners in the front view. This is nothing but A dash and B dash. There C dash and D dash. Out of A dash and B dash, B is hidden when you view it from the front. Out of C dash and D dash, C is hidden when you view it from the front. And the solid axis height is given in the problem as 65 mm. So from the base, I need to draw a dimension line with the height of 60 mm, 65 mm. In order to locate the apex point in the front view. This is nothing but O dash, and you need to join the base corners and the apex points. This is nothing but your lateral view of the solid, and the meantime you need to draw the axis of the solid also by the proper line format of the axis. You need to draw the axis. The axis line should be retained within the lateral view of the solid. It should not exceed top and bottom. Okay. So this is nothing but your lateral view of the solid. In the third stage, you need to include the axis inclination of 30 degree to HP, and for that simply you need to redraw this lateral view with tilted manner, and you should maintain the axis of inclination of the solid with HP as 30 degree. For that, first you have to draw a pilot line with 30 degree inclination with HP in a convenient position. With 30 degree inclination, I just drawn a pilot line, and here you need to redraw this lateral view with the tilted manner. For that, in the previous problem we worked with the prism. There the side edges are parallel to the axis of the solid. So whenever a side edge is tilted with 30 degree inclination, the axis will also retain as 30 degree inclination with the HP. But here it is not like that, because in the case of the pyramid, the axis is not parallel to the side edge. So you have to be very careful when you tilt this the lateral view of the pyramid with respect to the pilot line drawn recently. So what you can do is, in the paper itself we can follow a box method, but in this computer I am very much facilitated to tilt it. Let me to select properly. So I need to make the axis in line with the pilot line, and the meantime I have to ensure the one of the base edge touching the XY line in order to make the solid resting on HP by one of its base edge. Yeah, approximately I did, I think. Yes. And then you have to draw the projectors from the current front view towards the top view. From each and every corners of the solid. Including the apex point, and then from the previous top view also including the apex point. Yes. And now you have to identify the cut points for each and every corners of the solid, starting from A, A dash. I can log here as A. For your understanding purpose, I am making points in the cut, and point B, B dash can be marked here. Sorry, it's not a dash. Point C, C dash here. Point D, D dash there. And finally O, O dash here. And the corners of the solid can be joined as per the rule followed in the previous problem. As per the known rule, first you have to join all outermost points as visible edges. So by this rule, I needed to join all the outermost points as visible edges. Yes. And preferably before doing the starting this job, you have to have the list of various edges in the solid. So base edges, it's actually a pyramid, there is no choice for face edges, so side edges. In this, A, B, B, C, C, D and D, A are the base edges. O, A, O, B, O, C, O, D are the side edges. Totally 8 edges are there in this square pyramid. So out of these 8 edges, by following the first rule, what are all the edges joined? You have to have the notes. The edge AB is joined, the edge BC joined, the edge CD not yet joined, edge DA is joined. In the case of side edges, the edge OA is not yet joined, edge OB not yet joined, OC joined, OD joined. So the edge CD in base edges side and edges OA and OB in the side edges side are not yet joined. Let's do further. The second rule is join all remaining face corners as visible edges. Actually this is a pyramid, there is no faces there, so the second point is not applicable in this problem. And the third point is join all remaining base corners as invisible edges. So here the remaining base corners are only CD. You have to join this CD as invisible edge as per the third rule. So join the CD as invisible edge. So I think already you are familiar what is invisible edge and how to draw it. You have to use the dashed line format in order to join the invisible edges. edges. So the fourth rule is side edges. So the side edges can be decided whether they are visible or invisible by seeing the front view in top manner. So the edge OA and OB, they are the remaining side edges not yet joined. The side edges OC and OD are already joined by the first rule. So the edges, remaining side edges OA and OB are visible when you see them from the top. It's clearly visible. So you have to join them as visible edges. So this is what the end work in this problem. So here we just drawn a square pyramid when it is resting on HP by one of its base edge and the axis is inclined at 30 degree to HP. So one axis inclined to one plane and parallel to another plane problem. In our problem set, it's actually the second problem. Okay, thank you for watching, and practice this with your proper tools in your home very soon. Thank you very much.